Hi, this is AP Psychology. This is Mrs. Roberts. We are going to be doing a lecture today about research methods. We're trying to tackle targets 1.2 and 1.4. 1.2 being about learning and being able to differentiate between research methods, and 1.4 being able to criticize methods. Before we begin, you need to consider how are you going to consume this lecture. I've got some options here on the screen for you. One of the options is to use the link below this particular this lecture and to go ahead and open this, what's called a slide deck or a PowerPoint if we are using slideshows. So open the slide deck and save it into your folder for this class. And so inside of your Google Drive, there's a folder entitled Fayette County Public Schools. It also has this class inside of there. So you might want to create this new kind of slide deck, create a copy. You can take notes in the speaker area, or you can just listen. Another option is to create a Google document inside the folder for this class. And you might want to title it, research method notes or 1.2 and 1.4 notes, your choice. Other option, you can just take notes on paper and upload them on the end slides of this slide deck. You'll see those in here in just a second. So no matter what, make sure you have a reference somewhere in this folder on your Google Drive. That's one. Two, make sure that you're actually being attentive. So your memory can't work unless you actually are paying attention. So if you're listening to my voice and you're also trying to check, some sort of social media feed, that's really not going to help. I'm going to tell you why that's not going to help. So I'm going to talk to you a little bit about your memory. So you guys can see figure 1, the schema theory. So the first thing is I sense something. The second is I pay attention to. Whenever we're doing multiple things, and this is not to say that you can't multitask, but all of the research shows that if we're trying to do something, we're trying to commit to memory, that if we're not attentive to it, that it will not actually be encoded or placed into our memory. So today we're going to take special care to use our senses. So in this case, we're going to be using our eyes and our ears. And then we're going to be attentive, right? And then it says, I recall information from another memory. So we're going to try to connect what we're learning today to memories that you might have had in the past. And then it says, I activate the adequate schema. So schemas are just, think of those as like units or kind of folders that your brain uses to categorize information. So in order for you to remember something, it has to be placed or encoded into a special place so that you can eventually go back and retrieve it. So you see the last part of this is I respond. So we do know that just from psychology research, one of our kind of forefathers in developmental psychology is Jean Piaget. You might have heard of him before. We'll talk about him in great detail. We know that he found that all new information interacts with old information in this way. So your brain will automatically use cues to tell your brain where new information goes. So we're going to be trying to activate some schema, right? So we're trying to do this activation task. And we're trying to do this all in the efforts so that this is not just some boring lecture, so that you are actually trying to basically actively and metacognitively encode this. So what we're going to do is we're going to try to use a bunch of retrieval cues. So retrieval cues are memories held in your brain to basically act like anchors. So, for example, with the word fire truck, your brain holds the concept of a fire truck in a bunch of different places. It holds it in the same place that it might hold all trucks. The word red is also going to be a place where it holds fire trucks. So it's going to place it in a whole bunch of different places in order to allow you to retrieve the memory or to take it from your memory and to be able to use that. So if you've ever found like you couldn't recall something, so you're like, I know that we talked about that in class, but I don't remember it. That's because your brain didn't encode it. It didn't think it was important at the time. So I want to make sure you don't make that mistake now. So here are some cues, right? So I'm going to start to give you some stimulus. So this is visual stimulus. These are words or things that you might have seen in the past. So for instance, the word experiment or hypothesis, maybe data analysis. These might be people, images that you might associate with research, right? So varying types of research that we see in psychology. So your brain's working now. You might have seen something like this schematic. So quantitative versus qualitative data. So you might have, seen this before. You might have seen before the word survey. You might have concepts of the methods for collecting data. This is looking like a naturalistic observation, and this is looking like an interview. You might also think of research in the ways that it's applied, its objectives, or its mode. So those are all the kind of prior pieces of information that we might have about research methods, those in psychology. So now your brain has kind of activated where it needs to go, and it now is going to make it easier for you to retrieve this information. If you've seen the movie Inside Out, this is what we're trying to do, right? We're trying to create these memories that are located in lots of different places so that it's easy to find them. Some people ask me about chewing gum. They say, is it true at this point, of the lecture, is it true that if I chew gum while I'm studying and I chew the same gum when I take the test, that I'll be able to remember everything a lot better? The answer is maybe. Do you chew the same exact type of gum? And, every single time that you study this particular subject? Do you only chew it whenever you're studying this subject and then you don't ever chew it any other time? The answer to that is yes. Then the answer that I have is yes. And that's because what we know about our taste buds and our sense of smell, like our olfactory sense, is that it has a streamlined placement in your body to the hippocampus, which is the part of your brain that kind of begins the encoding process for memory. And that's kind of, for lack of a better explanation, sort of behind your nose somewhere. So it does have a more streamlined place. It also includes basically another place for your memory to go, which is in all of the places where your memories are stored with your taste and your sense of smell. So that just adds another stimulus to what you're trying to, another stimulus to your memory. So a smell, like another sensation, another smell, another taste, rather than just auditory and visual cues, which is what we normally use in education. All right, so a moment about methods of organization. So there are two ways that your brain is going to organize this information. One of them is called the centrality or importance model. So if your brain doesn't really identify this as information that it really needs to remember in a really deep, meaningful way, it's probably just going to store it inside of the folder. You guys can see where the words are kind of larger. So some of the tasks are larger that for sure goes with changing a tire. Maybe some of the other smaller things are like, you'll remember how to do that. Your brain's telling you these are not as important. But that these two are going to be the most important deals, right? Or maybe these three. So over here, another way that your brain organizes information is called the temporal order. So that's the order that events occur. So this is a procedural memory. Procedural memories are sort of a little bit more automatic when we create them. Think about the procedures that you take to wind down for bed or to wake up. Those are things that you don't really think about. They just happen automatically. If you're in a performance art, if you perform multiple times, your body just learns what to do one after the other, so much so that you can kind of go on autopilot. We're going to try to create something, like this for you, but we're also going to present this as well for research methods. So here is what those two models look like when it comes to research methods. So we've got the centrality or importance model over here and the temporal order model. We're going to look at those a little bit more closely. So generally speaking, we are presented with this information in a combination sort of way. So I've taken really, serious measures to make sure that I present it to you in both a temporal order, so an order of events. And you'll notice that not only is this order, here in the kind of preparation work, it's also the same in the quiz, and it's also the same in the remediation. So I'm trying to help strengthen your memory by using the same order every time. Now, when we test your memory, we want to jumble it up, right? But whenever we're just creating the memory itself, we want to try to remain very formulaic. Now, maybe in a couple of months, when you come back to this information, you won't remember the order, but you will remember those central terms. So that's why I use those bold vocab terms, because no matter what, your brain will be organizing this into a schema automatically. So we want to just make sure that we place the right words in the right folders so that whenever it's time to recall it and retrieve that information, that it's a little easier for us to do that. So today we're going to be talking about correlational studies and descriptive research. So we aren't going to be focusing in on experiments. Now, if you look at all of these words and you're like, yeah, I know what all of these things are. I did my homework. I've maybe taken, some upper level science courses. I might have taken AP statistics, and I understand how to calculate a correlational coefficient. If you're feeling really comfortable with all of this, then the rest of this PowerPoint or I guess slide deck will just be a review for you. But if you're like, I have no idea what she's talking about, I'll be going into some sort of detail and helping you understand what each of these terms really mean in the context of these research methods. So next class we'll be looking at experiments. All right, so this is our temporal order model. So you'll notice that there are some arrows. So for example, your brain, if it knows that the descriptive options are a case study, an observation, or a survey, and it also knows that for correlational studies, we also have a survey and an observation available. It just makes it a little bit more tidy in your memory, especially it gives you a visual cue to be using a chart like this. Okay, so let's start off with just research in general. So what's the relationship between these three types of research? So you'll notice that I created some arrows here and that kind of loops back around. So generally speaking, whenever we're looking at a kind of something we want to study in psychology, we start with a descriptive study. So what we start with is trying to describe an issue that's worthy of further research. So we're not trying to draw any conclusions. We're not trying to determine causality. We're not trying to determine relationships. We're just trying to see, is there even something here to investigate? So for example, let's say that the bathroom in the back hallway was always super overcrowded, at a specific class change. So the first thing we'll do is a descriptive study, and we're going to try to understand how many more times is that bathroom used than other bathrooms along the whole, in the entire school, along the rest of the corridor or the hallway, I should say. So once we get that information, it'll tell us, okay, do we really have something that's worth investigating here? Is the location of the restroom like an issue? So the next thing we got to do is some correlational studies. We got to understand the relationship between some variables. So we got to determine what those variables are. So maybe for us, it's going to be the time of day and the location. We have to understand, is the location of the restroom, which one's used based on the time of day, right? So is there any relationship there? If we find that there's some sort of correlation, so a relationship, then maybe we'll do an experiment where we try to understand what causes students, to use this restroom at this time of day. So we can't draw causality until we do an experiment. Now, we'll definitely find outliers, so people who don't really, fit the mold here. So if we see an outlier, then that means we're going to have to start all the way back over. So if we really want to understand not just the people who, the majority, we also want to understand the minority group too. We have to go back to descriptive research. We have to describe, more in detail what's going on with this group of people. So that usually leads us to some sort of case study, an in-depth analysis, or maybe an observation and recording, or perhaps even a survey. So we're assessing a sample of a population. So these are our two kind of methods that we're talking about today. So descriptive and correlational studies. We're going to try to put those together in your brain because I want you to remember the two types of studies from which you cannot draw causation. So we cannot say after either of these studies, well, I know for sure, that ice cream causes shark attacks. So we want to make sure you don't make that mistake. So you'll notice that there are two methods that they have in common. The two methods are observation and survey. So no matter what, whether or not you're trying to describe information, so just collect information and describe it, or whether you're trying to draw some sort of conclusion about the relationship between variables, you can use these methods. So in observation, you can either observe it in a natural setting or in a lab, or you can use a survey. Now, what they don't have in common are these two. So case studies, those are in-depth analyses of a single group of people. The reason why case study isn't inside of this correlational study, or isn't over here on this side, or in the middle, I should say, is because in a case study, we are not trying to understand the relationship between two variables that then we can generalize to the public. So case studies are special. We can't generalize that information to the public. Really good examples of case studies that you are probably familiar with are, like case studies of serial killers. We can't generalize what serial killers do to the general public, but we can study them in great detail so we kind of can understand them and describe maybe their motives, right? Now, when it comes to observation, recording in a natural setting or in a lab, those measures in either type of study, they do have to take on a very serious and scientific methodology. So, for example, when I was in third grade, my little 5-day quest teacher, she had me doing a science experiment where I tried to see the difference, if there was a difference, to remark on, is there a difference in the amount of time that third grade boys and girls could balance on the balls of their feet. So basically kind of like in releve for those dancers out there. So I was very interested in dance at the time, and she thought that would be a good fit for me. So I went into every single third grade classroom, and I timed the number of seconds that each child in every single class could balance on, on the balls of their feet. Now, it wasn't perfect. Why wasn't it perfect? Well, there were lots of variables. I didn't necessarily say I always did it the same exact time of day. So maybe in one class I collected all their data after lunch, and their calves were already kind of, hurting, or maybe they didn't drink enough water at lunch. I might have done it in the morning where there was, a little bit more, ability to hold that pose. So the problem with observation can sometimes be that it can take a long time, or that there can be lots of confounding variables. And that's why we always start over here with this kind of observation and descriptive research. So we can't draw tons of conclusions until we move all the way over here to experiments. But we can at least know, we can trust data that's collected in a methodological, or we can trust data that is collected using scientific methods. Now, a survey is also very important. So I want you to understand the word survey. So right now in our lives, we're seeing the word survey a lot. I think in the past couple of days, you've probably gotten a survey from the district. Now, whenever they use the word survey, it's not a scientific use of the word survey, right? So this is not exactly what we're talking about. So I want to talk to you about what it means to do a survey in psychology or in any science. So in order for a survey to be valid, it has to be representative of the population. So let's pop here. So this is a photograph taken outside of the Toronto Raptors arena. Right? So these are a lot of fans at the arena. So let's say that we wanted to find something out about the arena, right? So let's say that we wanted to find something out we wanted to create a survey for Raptor fans, perhaps about the type of, gear that they would like to purchase. So what we have to do is very formulaic. So the first thing that we have to do is identify the population we want to sample. So in this case, it would be like all Raptor fans, right? So we don't want to send a survey out to all Raptor fans. We probably wouldn't get very good participation. What we want to do after we identify the population is we want to gather demographic data. So demographic just means kind of descriptive data that's relevant to the experiment. So if the experiment is we want to understand what kind of gear that they would purchase, then maybe we need to understand, maybe gender would be important. So if you're buying like a gender specific item, uh, that's probably what's going to be relevant there. So what we do is we would take our population, and after we gather demographic data, we decide which demographic data was important. Like for example, if we were doing a study on restrooms again at the Raptor Arena, then maybe again gender would be important. So for step 3, we need to then group our population by that relevant demographic. So in this one, we see like a grouping by 3 different, like a demographic that's grouped in 3 different ways. So let's just say that this is blonde hair up here, this is brown hair down here, this is black hair in the middle, right? So once we've stratified our group by the relevant demographic, we want to determine how many participants from each group that we would need to create a sample of people that we could ask these questions, or that we could do this experiment on, or that we could observe that would represent the population well. So once we do that, once we identify the number of people we need from each group, then we would randomly choose participants from a group. Usually you do that using a random number generator. So once we get our sample, right, so this is our representative sample of the population, then we send out a survey, right? Then we do some sort of, then we send out a survey and we ask them questions that are pointed and that we hope represents the rest of the population, and that we are able to generalize to the population. All right, so these are just some kind of just a one-stop shop on what does this look like. So whenever we report information about descriptive data, so we know that in descriptive research, we're trying to determine the frequency of behavior. So let's say, again, we're trying to understand the number of times that somebody, that the population visits a restroom, or maybe we want to understand, what are the needs, what are the, merchandising needs of Raptor fans. Maybe we separate them in population by age, and we say, this major group is that kind of 18 to 50 crowd, and we say kids are another, anyone over 50 is in another group. So whenever we try to collect all that information, we're trying to gather it in some sort of way and then report it. So these are what reports look like in descriptive research. This is a case study. This is just like the outline of a case study. So this would be like 60 pages trying to understand this one group of people. This is an observation. So this is sort of looks a little bit more like a lab report. And then you guys have seen how surveys are reported very frequently. It looks like this. Very oftentimes like a bar graph or like an infographic. So the good thing about surveys is it's very easy to report them. So an example of descriptive research is, we've already used a lot of examples, but find the most frequent disease that impacts the elderly of the town. So you're not trying to understand the relationship between the elderly and the disease. You're not trying to understand what causes it. You're just trying to see what is the most frequent, disease. That leads us to this lovely graphic. So the first question is this descriptive data? So is this descriptive data? So let's look at this this chart. So we've got a death rate over here. We've got dates. You've probably seen this before. We've got the words Philadelphia, St. Louis, 1918 flu deaths, and we've got social distancing and effects. So is this descriptive data? Yes. So this is giving us some sort of information. There's a problem though with the title if this is descriptive data, right? So the problem with this title is the word effects. When we're just collecting information about the death rate, and in this case, the date, can we say that one thing caused it? No, we really can't. We can't assume that one variable caused another, right? So this title is problematic. The data itself isn't, but the title is very problematic. So what about this data gives us a clue that it's not causal data? So we know that it can't be causal because when we do a little bit more investigation, this is taking place in a couple of cities. There's too many confounding variables to say the effects of social distancing on deaths. Now, I'm certainly a proponent of social distancing, as any person who has any knowledge of disease spread would be. However, it's really ineffectual to title this graph this, right? So this doesn't make any sense. So what conclusions can we draw from this data? So we can draw some conclusions. Philadelphia had more deaths than St. Louis. Philadelphia had a spike while St. Louis had a more gradual rise. And then we need to do more investigation to understand what were some of the variables that might have caused that. Now, maybe one of the variables was social distancing. We did find that out, that there was some social distancing that happened in St. Louis. So we could find that through archival records, but we cannot necessarily say that one thing causes another. Certainly in a city where there are so many confounding variables. What if the population of St. Louis is overwhelmingly younger than the population in Philadelphia? What if Philadelphia is a major city with an airport hub, and 1918 is the end of World War I, or like a place for soldiers to disembark? What if this was the day that a lot of soldiers got home, or this kind of time period was when a bunch of soldiers came home and they always reported to Philadelphia? So there's a lot of information that this graph doesn't have, so we can't use the word effects unless we have that information. So what's missing from this data? Those are called confounding variables, other variables that could impact this data. So now let's move on to correlational research and how it is reported. So what do we use correlational research for? So we're trying to establish the existence of a relationship between two or more variables. We can use archival methods, we can use observational methods, we can use survey methods, so we can use lots of different methods. But all in all, whenever we're looking at correlational research in psychology, we're going to know that it is a correlational piece of research whenever we see scatter plots. So what are scatter plots? This is what they look like. So you've done scatter plotting before. This is an elementary school tactic. So you take information from a chart and you plot it on two axes, so on an X and a Y axis. And then in the next step in psychology is that you're going to try to understand, is there any relationships between these two, between all of these dots, right? So an example, just a funny one, is plotting like the visibility and prominence of a person or of a news source and its validity and accuracy. So whenever we're trying to plot that, whenever we're looking at the red dots, we'll see like there's some sort of line that we can mark here. This is called a regression line. But when we're looking at all the blue dots, we don't really see a correlation. So it looks a lot more like this. And this one looks a lot more like this. All right. So if you're interested in understanding how to construct a scatter plot and you didn't think that my explanation went far enough, I did embed a video here, so you're more than welcome to watch it. I do want us to understand how to interpret what we call a regression line or a trend line. So I'm going to go ahead and play this video for just a second. Actually, I think that whenever I play it, you won't be able to hear it. Let's see.
Shira's math test included a survey question asking how many hours students had spent studying for the test. The graph below shows the relationship between how many hours students spent studying and their score on the test. Shira drew the line below to show the trend in the data. Assuming the line is correct, what does the line slope of 15 mean? So let's see. The horizontal axis is time studying in hours. Vertical axis is scores on the test. And each of these blue dots represent the time and the score for a given student. So this student right over here spent, I don't know, looks like they spent about 0.6 hours studying, and they didn't do too well on the exam. They looked like they got below a 45, a 43 or 44 on the exam. This student over here spent almost 4.5 hours studying and got, looks like a 94, close to a 95 on the exam. And what Shira did is try to draw a line that tries to fit this data. It seems like it does a pretty good job of at least showing the trend in the data. Now, slope of 15 means that if I'm on the line, so let's say I'm here, and if I increase in the horizontal direction by 1, so there I increase by the horizontal direction by 1, I should be increasing in the vertical direction by 15. And you see,
All right, so if you're going, oh my gosh, I'm supposed to be knowing the rise over run and how to calculate things, that's not true. So I want to talk to you for just a second about what you're actually supposed to know about scatter plots in this class. So you really only need to know two pieces of terminology. The first one is called a regression line. So this is the single line that best fits the data. So if you've ever taken statistics, it's called the best fit line. It's represented by R in a mathematical equation. Here, mathematical, I'm not really sure. So that's this. So regression line. So this is the line. And then this next number is called the correlational coefficient. So it's essentially the number, and it can only be a number plus or minus one. So it can only be a number that's between 1 and -1. So think of it, this is kind of sort of percentages, right? So it can only be a number between the absolute value of 1. And what it does is it tells us essentially what percentage of the dots are getting closer and closer to that regression line. So, for example, over here we've got a perfect positive correlation. So the word positive in this regard just means as one variable goes up, so does the other. And negative isn't bad, it just means as one variable goes up, the other goes down. So when we have a correlational coefficient of 1, it just means that every single dot adheres to that regression line perfectly. So this means that there are no outliers in our data. It is a perfect correlation. This is very rare in psychology. So -1 just meaning that that line goes down as one number goes up, the other goes down. And then over here as +1, as one variable goes up, the other one does too. So generally speaking, our collection of our data in a scatter plot really looks a lot more like these middle guys here. So how do we know how do we know what this correlational coefficient means and how to read it? So you don't need to know how to calculate this number. It will always be given to you. But you do need to know whenever you're looking at a scatter plot if the plots look connected. And so in this terminology, we're going to use the word correlation. So we want to see, are there a lot of dots that start to go toward that regression line, which will always be plotted for you. If we see that, then we're going to see a higher number. So the number higher, closer to 1, right? So I think of this as sort of 80%. So 80% of the time, people's data adheres to the model that is one goes up, the other goes up over here. So we're starting to see that these variables these variables are related, right? Now over here are low positive correlation. So if we see the dots are just sort of all over the place, this is considered a low correlation. So this is a 0.3. Usually in psychology, we don't really call this like a very good correlation unless it really reaches above, let's say, 40%. That's the kind of number. So a 0.4, either negative or positive, is the number we're kind of looking for whenever we want to say something's correlated. And when there's no correlation, that means that the line is pretty much straight up and down. Now, what are some things that have a high negative correlation? One of the things we know has a high negative correlation is height and weight. As height goes up, we know that weight goes down. And the correlation is generally R equals -0.7. So that just means that whenever we're looking at it, we've got some dots, and it's generally speaking, as people's height goes up, their weight goes down, right? So we can say that with, some sort of, mathematic backing. All right. So what is a third variable or a confounding variable? So we need to understand that sometimes when we're looking at scatter plots, our data isn't going to be perfect. So let's go back here. So what we know for sure is that as ice cream sales go up, so do murder rates. We know that that connection it's got a 0.7 correlational coefficient. So just because as ice cream sales go up, murder rates do, that doesn't necessarily mean that these two variables are related in a way that we can draw some sort of meaningful relationship. In that case, what we're talking about is a possible confounding variable problem. Is there a third variable that is causing or that has some sort of relationship that's stronger between ice cream sales and murder rates? You probably know this, there is. So we do know that the weather is one of the variables that is going to be related to murder rates. Why is it the weather? Well, people go outside, they start to interact more, people get angry in the hot, right? So there's a lot of reasons why the weather is going to then impact murder rates. Now, does weather cause murder? No, right? Problems between people is a cause of murder. But we do want to see, is there a relationship between those two things? Whenever we see a relationship, then that allows us to move forward with more, with more data gathering. Now, there's also something called a directionality problem. So, for example, one of the things we know is that there is a strong relationship between exercise and happiness. So, as exercise goes up, happiness goes up. But so is, if we change the location of those variables, as happiness goes up, exercise goes up. So, we don't really know which one causes which, right? So, we can't even draw the conclusion of causation because we don't know the directionality of the relationship. We don't know if the direction is actually we don't know what's driving the relationship, right? So this is called a directionality problem. So generally, whenever we don't know the direction of the relationship, we just need more information. So oftentimes, the psychologist would just perform an experiment in order to determine causation. All right, so let's practice here. This is a scatter plot, and it says 63% of American adults can correctly read this chart. So I want you to take a second and notice that the bottom here, it says average sugar consumption, and over here, the average number of decayed teeth. So when we're plotting these dots, I want you to think about this for a second. So just use your common sense, right? So remember what we looked at in terms of the numbers of we're trying to kind of figure out what percentage of dots are close to the line. What number would you kind of come up with here? Would you say that this looks like that 80%, that 0.8, or do you think that that would look like more like a 0.3? So I'm going to go back really quickly so you guys can see that one more time. So this is a 0.8 and this is a 0.3. All right, I'm hoping that whenever you look at this, you can see that it's neither a 0.3 or a 0.8, that it's probably somewhere in the middle of there, but closer to 0.8. So I would say that this, just spitballing, because you don't really need to know how to calculate that in this class. That's if you wanted to become a psychologist, that you probably have to learn how to calculate this. You'd have to take a statistics course. So this is about, somewhere around 0.6, maybe 0.7, somewhere in between those two numbers, right? So a positive because the line goes up. So as one goes up, the other one does. So what is the correct kind of conclusion we can draw? So the right answer here is the more sugar people eat, the more likely they are to get cavities. That is what we can draw from this chart. So we always want to make sure we're not falling into the causation trap. We're not using the word cause here. So what type of chart is this? Hopefully you remember, it's called a scatter plot. What type of research is this? If it is a scatter plot, hopefully you remember that's matched with the correlational research. And which phrase in answer choice C makes it correct? More likely, right? So I hope that you remembered that one. So that we're looking at correlation, not causation. I wanted you to double check your homework with this chart. So making sure that whenever you are comparing these, so you guys were only in charge of these two rows, making sure that you have noticed and noted that you already came into this lecture knowing the advantages and the disadvantages of all of these types of research. All right. So this is your optional area to upload your notes. So if you've used this as your note-taking area, a piece of paper, this is an area where you can maybe take pictures of your notes and upload those there. All right, thanks for listening.